right, so this is kind of like a 2-7 day 2 with some review in there. But we're going to actually start off with looking at how we do an segment bisector. So we want to open the compass a little more than halfway and then place the tip of our compass. So I'm going to do it up here on this one. So at least going more than halfway, and then we're going to keep it there at that same distance and go the other direction with it. And then we're going to draw a line from, they're called P and Q, on the down line below. And so now we have bisected the segment. Okay? So it's a draw a line from P to Q. There we go. Label the intersection of AB as point M. So M if we drew our line. So M is the midpoint of AB. Let's explain. So yes, M is the point of intersection of AB, and its bisector. So yes, M is the point of intersection of AB and its bisector PQ. So by definition of bisector, then AM is equal to MB. So M is the midpoint of AB, segment AB. Oh, make sure I get it all on there. All right, so now for step A, why do you need to open the compass more than half the length of AB? Well, this ensures that there are two arcs will intersect. So ensures the two arcs will intersect. And we need them to intersect so that we can get our points and draw our line there. Okay, so we're going to construct an argument. How are the lengths of AM, MB, and AB related? So write one or more equations to express that. Well, we know that AM plus MB is equal to AB, and AM is equal to 1/2 AB, and MB is equal to 1/2 AB, and we know that AM is equal to MB. So there's some equivalence that we can see there. Right, let's take a look at the next page here. So for our segment addition postulate, if we're looking at our picture here, we know that AB plus BC is equal to AC. We can go ahead and kind of construct an argument here. We've already got a lot filled in, and it's kind of already giving us some hints. So let's take a look at that. Well, congruent segments have equal lengths, then we know congruent are equal. You can also use definition of congruent. So we're just changing those into equality statements. Now, what is it that PR is equal to PQ plus QR? Well, that's going to be adding segments, isn't it? So that's the segment addition postulate. And then up here, we know that's given. So we can make sure we put given in there. Next, it looks like we are putting this in for PR, putting this in for PT, and they're equal to each other when we use that substitution property of equality. I'm going to switch to a darker pen so you can kind of see it a little bit better here. All right, now it looks like the only change is we're replacing this QR or this ST with QR, which we know are equal from step 2, so that's another substitution. Now PQ is equal to PS. Well, it looks like we are just getting rid of QR and QR on either side by subtraction. Property of equality. All right, now what's our final thing that we're trying to prove? Oh, it's up here, that they're congruent, and that is the segments with equal lengths are congruent, or definition of congruent segments. And there we go. All right, so in the second step of the proof, why is it necessary to change the given statement about congruent segments into segments with lengths? Well, we're going to then transition into segment addition postulate, and it doesn't refer to congruence anymore. It refers to things that are equal. So the proof depends upon using that segment addition, and that requires lengths. So using segment addition postulate, we use lengths. So it's necessary to convert the congruence statements into lengths. All right. And then down here, extend the line segment SV to the line segment RU, and let W be the point where they intersect. Write a paragraph proof. We're going to actually skip that example, but you're more than welcome to try that if you would like. But we're going to move to our flowchart proof next. So let's take a look at that next page. All right, we have a ruler postulate to start with. So with the ruler postulate, we are collinear. Then point Q is located between P and R. There we go. And if and only if PQ plus QR is equal to PR. So then down here, we're going to kind of fill out this flow chart proof, kind of graphic organizer type stuff. So it looks like we're going from congruent to equals by the definition. Oh, let's spell definition right. Definition of congruence. Okay. Now we're going to move our way to here. It looks like they're putting QR equal to UV because they're both equal to ST. So taking the first, taking the last, putting that together is the transitive property of equality. Now we're moving from equals to congruence. So again, that's definition of congruence. Or congruent segments is fine too if you want to get specific. All right. And this last one, how do we remember basically the difference between the ruler postulate and the segment addition postulate is ruler postulate uses 2 words, segment addition uses 3, and so a way that you could remember that is the ruler postulate has 2 points in the statement, and then segment addition postulate has 3 points in its statement. So that's one way that you can remember that.